Welcome to Mr. Psycho, where we dive into the mysteries of science and nature, exploring the phenomena that often seem to defy logic. Today, we're going to look into a phenomenon that's as powerful as it is mesmerizing: the Magnus effect. You've probably seen it in action without realizing it: a soccer ball curving into the goal, a tennis serve that suddenly dips, or a baseball pitch that swerves. This strange, almost magical curve that seems to defy the laws of physics is the Magnus effect, and it's rooted in some fascinating science. To truly understand the Magnus effect, imagine you're standing on a field with a soccer ball. You kick it, but instead of just sending it straight, you add a twist. The ball begins to spin as it soars through the air, and something remarkable happens. Instead of flying in a straight line, the ball curves, slicing through the air in an arc. What's going on here? Why doesn't it just follow a straight path? The Magnus effect occurs when a spinning object moves through a fluid, like air or water. As the object spins, it pushes against the air on one side, while the other side is moving in the same direction as the airflow. This creates a difference in pressure on either side of the object. Imagine a tennis ball spinning through the air. The side of the ball that's spinning against the direction of the airflow will have higher pressure, while the other side, moving with the airflow, will have lower pressure. This imbalance in pressure generates a force that pulls the ball in the direction of the lower pressure side, causing it to curve or dip. This phenomenon was first observed by physicist Heinrich Magnus in 1852. Magnus was experimenting with cylindrical objects in a lab, watching as they spun through the air. To his surprise, he noticed that the objects weren't following a predictable path; they curved as they traveled. This discovery was groundbreaking, not only explaining why balls curve, but also unlocking a deeper understanding of fluid dynamics and aerodynamics, fields that are crucial to how we design everything from sports equipment to airplanes. The Magnus effect isn't just a fascinating trick in sports. It's a principle that has practical applications in the real world. Engineers and scientists use it to design better performing equipment, from golf clubs to baseball bats, maximizing the potential for spin and control. The Magnus effect even plays a role in the design of large cargo ships. Some modern vessels are equipped with tall rotating cylinders called Flettner rotors, which harness the Magnus effect to generate additional lift. By spinning these rotors, ships can harness wind power to improve fuel efficiency, moving more swiftly across the ocean with less energy. This phenomenon also helps explain why certain projectiles behave in surprising ways. In fact, the Magnus effect is a key factor in military technology. During World War II, artillery shells were designed to spin, using the Magnus effect to increase their accuracy. Even the infamous curveball pitch in baseball owes its uncanny motion to this effect. With the right spin, pitchers can throw balls that seem to break the laws of physics, dipping or curving just as they reach the plate, deceiving even the most skilled batters. In sports, we see the Magnus effect all the time. When a soccer player curves a ball around a wall of defenders to score, they're skillfully using the Magnus effect to their advantage. Basketball players use it on free throws, aiming to get a softer arc and a better chance of landing the ball in the net. Tennis players use spin to control the ball's direction and bounce. With each spin, these athletes harness a natural force, transforming a simple shot into a display of finesse, skill, and science. At Mr. Psycho, we're here to show you the magic hidden in the world around us, the science behind the seemingly impossible. The Magnus effect isn't just a lesson in physics, it's a reminder of how the world is full of unseen forces, quietly shaping everything we see. So the next time you watch a game, pay close attention. You'll see the Magnus effect in action, bending reality just a bit, giving athletes a mysterious edge, and reminding us of the power of a single spin. Thanks for tuning in to Mr. Psycho, where we unravel the science, mystery, and hidden power of the world around us. If you're intrigued by these strange forces, be sure to subscribe, like, and hit the notification bell, because we have plenty more mysteries to explore together. Welcome to the journey, and remember, sometimes a small twist can change everything.